Like I showed you an area model. Are you filming me?
Filling out.
Oh, shoot, I should be doing a better job then.
Hey, Linnea.
Hi, Linnea. I'm kind of just jumping all over to give you some scoops, but okay. Later on, what will start to happen is you will learn a whole bunch of convergence tests for series. And one of them is going to be the improper integral test, where you treat it like, if it behaves like a function, if you plotted each one of these terms, then you'll be able to tell whether it converges or diverges. That isn't in your notes right now. What she wants you to be able to do right now, I think, is write out the first few terms of the series and then decide or verify that the sum is going to diverge. So I think you have enough information to kind of muddle through that.
Can you give another example of a harmonic sequence?
Anytime a harmonic is defined as any, the denominators are an arithmetic. So it could be like this is the classic harmonic, but any time the denominator would be an arithmetic sequence, which would be like if it were 1/4, 1/6, 1/8, 1/10 would also be one, or even another variation of that would be if you had a constant in the numerator, like 3 halves, 3, just any constant multiplier would work too. So that the basic deal is if the denominator is an arithmetic sequence. So what happens in this a lot is it's easy to lose track of what you're really doing. And so the whole chunk of work with series that you guys will be working on is a number of different tests, like probably 10 different ways to decide whether the sum of all these is going to converge or diverge. So the first two simplest types are geometric and harmonic, and those are ones that if you can classify them, they follow, they're kind of one of our known ones that we don't have to do a lot of work with. And then there are going to be telescoping and some other ones. So I think as I look at this homework, they're just trying to get you used to the idea of what an infinite series means. It means if you added them all up forever, what would the sum be? And then having you visualize how they would look on a graph, and also having you get used to summation notation and how to write out the first few partial sums. Did she go over what a partial sum is? A partial sum would be if you, what's the sum of the first 4 terms? What's the sum of the first 5? The sum of the first 6? So you can see what the running total is doing behaviorally, which is actually what we did here. The partial sums for this series that we sketched visually would have been 16, 24, 28, 30, 31, 31.5, 31.75, you with me? And then you could see that it's approaching 32. That's the idea of partial sums. And so that when you see that, that's what will happen. So I think you have a basic idea to give these a shot, and then she'll have a whole unit for you of a whole bunch of different integral tests that you'll kind of learn to basically test whether stuff converges or diverges. And that's really the only Calc 2 concept that you guys haven't covered. You're going to spend this is a big chunk of the Calc 2 material, is the stuff on sequences and series. So you have a long way to go to learn more of the rules. So